This is Mrs. O'Neill for your Chapter 3 review questions and problems. You might want to pause here though and look at this picture or this diagram or this scheme, this what would they call the stoichiometry map, just to again familiarize yourself with the fact that we can start at any one of these given units. We can use the balanced chemical equation to get from substance A to substance B, and then of course go to any of those given or finding those units. So again, we just want to remember that stoichiometry is just a way of getting from one substance to another, but we always need to be in the mole unit in order for us to do that. So you're going to go through the video by pausing when you see the question or problem. Again, multiple parts at some numbers. You can do them mentally or on paper, but strongly suggest you putting them on paper, especially the mathematical ones. You might want to have out your calculator as well as your reference sheets. You want to then play the video to see the answers and or the solutions or game plan. And some of these are going to be above and beyond what you're going to see on the test, but they're going to be very helpful for those free response AP questions. So number 1, you should have paused and tried to write a balanced equation for A, B, and C. Number 2, and here's your answer again to A, B, and C using the mole island or again dimensional analysis. Number 3, and here is your answer. Again, pause, and you might want to look through all that. If you have the correct answer, that means whether you did it this way or another way, you're good. But if you're still not getting what you should be, again, kind of take that moment and pause and go through the solution little by little. And this is also a good chart to use. We're going to be seeing this when we deal with equilibrium, which doesn't come for quite a while, but this kind of shows you what we call the ice box, or some people call it the rice box. In other words, it's talking about the reaction. It's talking about what you have initially, what your changes or how much reacted, and then what your final, or what would be, in this case, equilibrium, what would be your final answer. So very similar to what we're going to see later on. Number 4. Now this one again is quite tricky because you have 3 reactions, but you're dealing with 1, 2, 3, 4 things that you are trying to solve for. So again, I'm going to show you the answers first. So here's your answers. If you got these, great. Hopefully you got them similar to the way I'm going to show you the solutions, but if not, that's okay. But here are the solutions. So this is how you would, this is my game plan. I would have out the reactions and I would have the information they give underneath the substance, just like I'm doing a stoichiometry problem. And again, what else is given to us is how much CO2 is total. Then guys, it's really a stoichiometry problem after a stoichiometry problem after a stoichiometry problem. So here's how we would find the KClO3. Here's how we would find the KHCO3. Here we would find the K2CO3 and the K2CO3. Again, using stoichiometry 2 times in order for us to figure that out because of the 2 different equations that the CO2 is in. All right, so hopefully that made sense. And then the KCl at the end, the easiest thing to say, if we have 100%, we basically start out with 100 grams, and then I'm just subtracting. All right, number 5% yield. Again, you should have paused. There's multiple parts here, so hopefully you took the time and used your resources and came up with an answer for A. Again, using stoichiometry, came up with an answer for B. And again, this one, hopefully you're understanding this. If you have 80%, you basically need 1 out of 0.8 or 1.25 times as much to obtain that same amount of product. C. This is your normal limiting reactant problem, basically. But how do I do that? I do two stoichiometry problems first, find the limiting reactants in terms of moles, which one has the least number of moles, and then I finish the problem. D, you should know this formula or equation. All right, good luck on the test.